So, you guys ready? Okay, I'm going to share a screen. Okay. Share screen. Okay. Can you guys see the PowerPoint? All right. Holler at any point if you are confused or anything of that nature. So we're doing, as stated, we're doing 2 examples. Oh no, my files. So we're doing 2 examples and then we're doing the actual problems. So basically, you know how in the problems that you guys did yesterday, you were like converting an X thing to a Z-score, and then you were going in the back of the table and finding the probability, right? Like nodding. Okay, now what's happening is I'm giving you like a percentage that I want the probability to be, and then you have to go back and find what Z-score it is. So in these problems, it's actually like you're going to be starting at the table and then finding a Z-score that goes with that, if that makes any sense. So, and then there's 2 tricks with it. So first one, we'll do an example. So we're going to find a Z-score. So again, we're looking for the Z-score. So that 66% of the data lies to the right of the Z-score. So what I like to do is I like to just like literally draw this out. Let me get this. Okay. So like I'm going to draw a normal curve, and then I'm going to say, okay, so I'm looking for some kind of a Z-score. I'm going to put it like to the right or to the left of the mean, because what I'm saying is 66% of the data needs to be to the right of that Z-score. And so I'm looking for that Z-score. But the only trick with this is you have to know from your table what, like your table always gives you the Z-score or the probability that is to the left of the Z-score. So whenever it says something like to the right, we need to right away start with, okay, well, if that's to the right, what would be the number of the Z-score in the table? It would be okay, so if this is 66, this is going to be, what is it, 34? Because I'm just doing 100 minus 66. So if that's 66 over there, then this is going to be 34 over here. And so the number that I'm looking for in the table for the Z-score, I am looking for what Z-score gives a table value. And you know how the table always has 4 decimals? I'm going to be looking for like 0.3400 essentially. That's what I'm looking for in the table. And then the answer is going to be whatever that Z-score is. Lindsay, is that a hand?
No, I'm scrolling on my, sorry.
No. Are you guys tracking with me so far?
Yeah.
Yeah, Patrick, you good? Okay. So now like look at the table and you got to find, so we're looking for in the table 0.3400. And the only thing that gets kind of tricky is like there's not necessarily going to be an exact 0.3400. So like I always just kind of start, all right, so here's 0.02, so I want something way bigger than that. Here's like 29, so it's still going to be bigger than that.
Negative?
Right, so it's definitely going to be a negative Z-score for sure. For sure. And that actually makes sense because you know how at the mean you'd have 50%. So since we're looking for, what was it, 34%, it's definitely going to be the left of the mean.
0.041.
Say again?
Negative 0.041.
Okay, yeah, so negative 0.041. So, and now actually see how 34% is not in the table. Oh no, if 34% were in the table, it would be stuck. Oh, dang it. Close. Okay, 34% would be right between these 2 guys. It would be right between 0.3409 and 0.3372.
Yeah.
So how you're going to handle that situation is we're going to see which one is closer. If one of them is closer, you're going to pick the closer one. And then if they're exactly the same distance apart, then you're going to go to the middle of those 2 things. And we've got an example with this one. So how I look at this is 0.3409, that is 0.0009 above. I like to just look at these last 2 numbers. Like this is 9 above. .33.72, that's like, let's see, 72 to 100 is going to be like 20, why can't I think right now, 28. So this is 0.0028 below. This is 0.09 above, which means that this one's closer. So just what you said, Lindsay, of negative 0.41. That's the answer. That's the z-score, so that about 34% of the data lies to the left and 66 of the data lies to the right.
Okay.
Jack Augustine, how you doing? Oh, you're on mute.
I got it. I think I'm good.
Okay, you think you're good. Anybody else, holler at me if you are not good. All right, in the absence of any hollers, let's look at another example. So here's one. Find a z-score such that 49.8% of the data lies to the left of the z-score. So it's helpful for me to draw a picture. So if I'm drawing a picture, I know that this is 50% at the mean. So I'm looking for a z-score that's probably going to be like right here. I'm looking for what z-score has 49.8% of the data to the left. Now, do we need to do like a 1 minus or anything, or are you just looking literally in your table?
Just in your table.
Literally looking in your table, and that's because it's why?
Left.
Left, yeah, to the left, everything you own. Okay, so here's a z-score table. What are you looking for in the z-score table?
0.498.
Yeah, 0.4980 technically. So you know that like 50% is at 0, 0. So you probably, you're going to be just a little bit to the left. Oh my. So here's 0.48, like 4880. And then here's 4920. So both of these are technically like if you're just looking at the last two numbers, they're 20 away, because 80 is 20 below, like 0.002 below 49. Oh wait, dang it. No, we have literally 49. I'm sorry. Anybody else catching this that it should be between here and here. Between here and here. Oh no, this is a bust. You guys see why it should be 4980? It's gonna be between the 50 and between the 4960.
Yeah, so it's 0. What? 0.
So it's like, since this one is directly between these two, because it's like 0.002 below 50 and 0.002 above 4960, you're gonna go with the very middle. So it's gonna be, this would be 0.00, this is 0.01. So you're going to be at 0.005. If you add a 5, negative 0.005. If you add a 5 in between those, then it'll be where it needs to be.
Okay.
Okay. Let's actually just do your homework. So if you have a pen or whatever, now's a good place to get it out. We're going to start with 15. Because remember, you're doing 15 through 27 and then 29. All right, so 15. You're looking at find the z-value so that 6% of the standard normal curve lies to the left of z. So if you're drawing it out, 6% is going to be probably pretty low. I'm looking for this z-score. So what are you looking for in the table?
0.06.
0.06. And technically, because the table has 4, I'm just going to write out like this. I'm looking for this, 0.0600. That's what I'm looking for in the table. So here's your table. I'm looking for 0.0600.
Negative 1.5.
Negative 1 point what?
Negative 1.5055.
Okay, yeah, because so 0.600. So it's going to be somewhere, it's right between this one and this one. And Lindsay, why are you adding a 5 there?
Because it's in between, it's perfectly in between 0.05 and 0.06.
And how do you know that it's perfectly in between?
Because 0.0606 and 0.0594 are both 0.006 away from the number we're looking for.
Yeah, they're both, so that's negative 1.55. This is negative 1.54. So it's going to be right in between these two because they're both 6 off.
Mm-hmm.
Did you say negative 1.555?
1.5055.
Well, the 5, okay, so this number, negative 1.5, and then this is a 0.5 up here. This one is negative 0.55, negative 1.55. And then this one is negative 1.54. So the thing right in between them is negative 1.55545. Oh my gosh, I'm so sorry, that's not my day. Negative 1.545. And you could get that if you literally add these two things together and divide them by 2. If you're not sure what we're doing, add those, if it's right in the middle, add them together and divide by 2. But most often, we're going to have one that's just closer to something in the table. Patrick, how you doing? Yeah, like, give me some feedback. Are you guys like totally lost on this, or how are you doing? Rocco, how are you doing?
I'm good so far. I get it.
Okay, how about the like between stuff?
I mean,
That's kind of weird, but
yeah, it's weird, but like I kind of get it, I think.
Okay.
I had negative 1.555, but
And yeah, Patrick, the reason why you go with the lower number and out of 5, because like the negative 1.555, that would actually be the next one. That would be closer. That would be between 1.5 and 1.56 if you go with the bigger one. And if in doubt, just add the two together on your calculator and divide by 2.
okay.
What's the answer?
So the answer is negative 1.55545.
Okay. Let's do the next one.
Let's do the next one. All right. So you are finding the z-value described and sketch the area such that 55% of the standard normal curve lies to the left of z. So this is another lefty. What are you looking for in the table?
0.55.
Yeah, you're looking for straight up 5.5 in the table. So here's your table, look for 5.5. And you already know, like just from the number 55, are you looking on the positive side or negative side?
Positive.
Why?
Because it's over 50%.
Yeah, it's over 50%, so automatically it's going to be right in the positive side. So you're looking for 55%, like 0.55. Anybody seeing it?
Yeah.
0.13.
What did you say, Jack?
I have 0.13.
0.13. And then why did you pick this one instead of 0.5478?
Sir.
You picked right, Jack. You know why you picked that one?
Because 0.55. So I picked it. I don't know the
Okay.
actual reason.
Here's one. How about this? If this was 0.5530, let's say that. This one was 0.5530 and this one was 0.5478, would you still pick this one?
No, I don't know.
Okay, think about it.
Is it just what everyone's closer?
Yes. So if you're looking at the 78 one, the 5478, that's like, think about the distance from 78 to 100. That's going to be 22 below. And the one that you initially picked is only 17 above. So this one's 22 below, this one's 17 above, which makes this one closer. But if it had been like 5530, then the 5478 one would have been closer. Does that make sense?
Yeah, I got it.
Kind of. Okay, so Jack was right. It was 0.13. Did you say 0.13? Because that's the 0.1 and it's 03. So 0.13.
We say what was 16?
16? What'd you get?
We skipped 16.
But she already did it. What'd you get?
I got negative 1.63, but
Good job. That's correct.
okay.
Okay, free answer, everybody. You can write that one down. Then just make sure you do the work to check it. Check and verify.
What was that, Anna?
Negative 1.63.
Thank you.
Did you get that too, Jack? Or how are you doing it now?
Yeah, I got the same thing. Yeah.
That's a beautiful thing. Glad to hear it. Okay, Izzy, you still alive over there? Izzy's left the building. Autumn, you still alive over there?
Yes, I'm still here.
Oh, good,
Yeah,
good,
my
good.
cat's just meowing a lot.
Classic, classic, classic. I'm watching the Big Cats Want thing on Netflix. Fascinating, or King or whatever. Anybody else watching that?
No.
I recommend it. Okay, let's do the next one. Here's number 19. Find the z-value described and sketch the area described so that 8% of the standard normal curve lies to the right. Ding, 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 ding. Alarm bells. It's to the right. So what's that mean?
At 0.92.
Yeah, you are looking for, so here's my z-value. If I want 8% over here, then 92% over here. So I'm looking for the 92 in my curve. So I'm looking for 0.9200. All right, here's the chart. Find it. And right away, you know you're going to be looking on right side or left side.
Right.
You are right. Okay. All right, anybody finding it?
Yeah, I got it.
What is it, Jack?
1.41.
1.41. Okay, and why did you choose that instead of 1.40?
It was closer.
Yep, exactly. This one is 7 above, this one is 8 below, so go with this one. So the answer is 1.41. Good job, Jack. Hey, just because we're here, how about we do 20? I didn't put it on here, but 20 is, what is 20? 20 is you're looking for 5% lies to the right. So I'm just going to leave this one up. I'll write it on. So 20, number 20 is you're finding the z, so that 5% is to the right. So what's on that? What are you thinking? What do you got to do first?
You have to look for 0.95.
Yeah, so you're looking for 0.95. You're looking for 0.9500.
$1.65.
1.65? Okay, how come?
Well, and 4 because they're 5 apart. They're equal.
Yeah, you got it, Izzy. So this is that weird situation where this is 1.64, this is 1.65, and it is exactly in the middle of these two.
Do we just put 1.645?
You got it. 1.645 because it's exactly in the middle. And again, if you forgot how to do that, just add the two together and divide by 2. Good job, Izzy. That was Izzy, right? I think so.
Yes.
Okay. Okay. All right. I think you guys we'll skip 21. I think you're good on 21. Let's do 23. This is a different kind of problem. So this one is you are finding the z-value such that 98% of the standard normal curve lies between negative z and z. Yeah, so this is a between one. This is different. And I think the key for this is that you draw it out. If you just draw it out, you know that your normal curve is symmetrical. Mine is not, but yours is. So this is the mean right here. That's the mean. Oh boy, here we go. So that's the mean. So I want to find, so if here's my negative z and here's my positive z, I know that between these two numbers, there is 98% of the data. So any thoughts? What else could I fill out in that normal curve? If I've got 98% of the data here, can you figure out what's to the left of the negative z or to the right of the positive z?
1.
Why is that?
This is just 1% on each side.
Yeah, and how'd you get that?
It was 98.
Like you got to get to 100. So you're essentially doing 100 minus the 98 divided by 2. And that's what's going to be on each side. Okay, so what are you actually looking for in the chart then?
I have no idea.
Anybody thoughts? What's the easiest way to do this? What are we looking for in the chart?
Negative.
Look for the two that are in between 0.01.
Yeah, I would do that. Let's find this z in the chart. Let's find the negative z in the chart because that's kind of the simplest. If we know that 1% is to the left, let's look for 0.01 in the chart because that is the simplest way to just go straight to, okay, well, that's going to be something to the left. Okay, so you're looking for 0.01 in the chart. Here's your chart.
Is it negative 2.32 and negative 2.33?
Like, which one are you going to choose for that one?
That one, right there. Those two.
Yeah, but which one's it going to be closer to?
The negative 2.33.
Yeah, because this one's like one below. So the value that goes with this is negative 2.33, and this is only just a little bit below. So we're going to pick this value, negative 2.33.
And that's the answer?
That's the answer. So if we were going to go back, it would be negative 2.33 and positive 2.33.
So you put positive too?
Yeah, because you're trying to find the negatives. Like in the problem, it says the negative z and the positive z, but like you found the negative one, so the positive one's just going to be the positive version of that.
Got it.
How about try on your own? Try 24 is, I want you to find the z value so that 95% of it lies. 95 is between z and negative z. So it's the same problem. This is number 24, but it's going to be 95% is going to be between z and negative z. So give it a stop. Let's just start out.
Going on an airplane?
We're about to take off on a wild statistics ride.
Dad, can you show the chart?
Absolutely. And first off, Izzy, what are you looking for in your chart? BT dub.
Oh God. I put 0.0250.
I love it because if this is 95%, the other side has to be 5% that's left over divided by 2. So both of these is 2.5%, 2.5%. So you're looking for, that's a negative z, that's a positive z. So you said 0.0250, right?
Yes.
Beautiful. Okay, so here's your chart. I will erase.
Is it negative 1.96?
Yes, it is. It is.
And
Negative.
positive. And positive.
Yeah, negative and positive 1.9. I'm trying to find it here. 6. Oh, and look at this. This one is an exact value. What a diamond in the
Yeah.
rough here. This hasn't happened yet before. What a beautiful thing. Okay. All right, next one. Word problem. So, word problem. I cut out a lot of the crap. That was the way that the word problem was written, but here's the situation. X is a random variable that's measuring the milligrams of glucose per deciliter of blood. After a 12-hour fast, the random variable X will have a distribution that's approximately normal with a mean of 85 and a standard deviation of 25. So you're trying to find the probability that after a 12-hour fast, X is more than 50. How do you start? Anybody?
I'll do it.
What are you going to do, Sweeney?
So X is more than 60. So first you have to do 60 minus the mean divided by the standard deviation. So 60 minus 85 divided by 25, which gives you -1.
You got it. His first thing is just change it to a z-score. So we're finding the probability that z is greater than or equal to -1. And then what would you do from there? Like, how do you actually find the probability that z is greater than -1?
So then you go into your chart and you look where it's -1.0 since there's no decimal,
Mm-hmm.
which is 1.1587.
Mm-hmm.
And since it's more than, that's basically to the right. So you have to subtract, you have to do 1 minus 0.1587. So
Yeah.
that'll give you the answer as 0.8413.
Yeah. Good job. Hey, any questions on why you're having to do the 1 minus part?
Well, how did she know it was to the right?
Good question. How'd you know that, Hannah?
Whenever it says more than or greater than, it's always to the right. And when it says less than, it's to the left.
Okay.
So I remember it as like less than is left, like 2 L's.
Oh, that's good.
And then the other one, I just think it's just the opposite.
And I don't know if it would be helpful if you drew out a chart too, but like if you draw out this normal curve, the thing from the chart is always to the left side. So we know that 0.587 is this area, but I'm looking for it being greater than. So I'm looking for this area, which is why you have to do the 1 minus, which that's 0.8413. Okay, how about B?
We have to change 110 to a z-score, right?
Love it, Izzy. Good job. And this one is less than, so right away you know that when you're doing your chart value, are you going to have to do 1 minus?
No.
No. So this is the probability that z is less than, everybody get it already?
Are you asking me?
Oh, anybody?
15
don't have
divided
my
by
calculator.
25, but I don't know what that is.
Wait, when you did 110 minus 85, what'd you
Oh, sorry. It's 1.
Good, okay, good. Thought I was going crazy for a second. So it's probability that z is less than +1.
It's the same thing as A, but the sign is flipped.
Yeah, well, like the -1 and the +1. So like your answer though is the same thing. Your answer is 0.8413. Yeah, oh, wrong one. So yeah, 0.8413. All right, and then how do you do the betweens?
You subtract something from something.
You do
Like the bigger
subtract-
number from the smaller number.
Absolutely, and no one minuses. So probability that, let's see, 60 is less than or equal to x, oh my, which is less than or equal to 110. And we already found those z-scores. So that's the probability that -1 is less than or equal to z, which is less than or equal to 1. Doing a picture down here. So picture, oh boy, sorry guys, technology, obviously not my day. Okay, so I'm just doing a picture down here of here's +1, here's -1. I'm looking for the area in between here. So anybody remember what you subtract?
Is it like that, the normal standard curve 0.6 something? 0.68, 68%?
You know what? That's exactly right. Yeah, you could look at it that way. Within one standard deviation of the mean is 68% of the data, which is true, which is also the answer you get if you go into the chart and you just look at -1 and +1, and we're going to subtract it. So like you're going to subtract the +1 because that's the right, and +1 we just got was 8413. So we're going to do 8413 minus 1587. So 0.8413 minus 0.1587. Wait, isn't it? Which is 68.26. So just like, that's what we say. But essentially 68. All right, last one, probability that x is greater than 140. How about you do it on your own and we'll check it? Because I think you guys are doing just fine. Hey, while you're working, how's the, now that you've pretty much gone through all your classes once or twice with this new schedule, how's it going for you guys? Do you like it better than last week or worse?
Worse.
So, wait, who says worse? Really? How come?
It's
Not
horrible.
good.
Like, tell me about
It's just like more stressful.
it. Really?
For stuff, I'm overloaded.
Yeah. It's more to keep track of and more to do. So like I'm kind of fine like with time management and stuff. Like I can see how people that can't manage their time well might benefit from it, but for me it's just more stuff to do.
Yeah,
I agree.
same. I kind of like think about like what times, like all the time.